Thank you for joining for this episode of the TechSpective podcast. My guest is Mr. Ed Kim. So Ed, if you could introduce yourself and give a little bit of background.
Absolutely, Tony. So my name is Ed Kim. I'm the Vice President of Education and Training for Code Ninjas. I come from Georgia Tech. I'm a proud graduate of Georgia Tech 2009, but I'm not a traditional engineer. I was on the management business side of things, but I've been working in K through 12 tutoring and after school programs since I graduated. I came recently from more traditional academic tutoring in that sense, SAT, ACT, test prep, college admissions, GPA management. And I joined Code Ninjas about 9 months ago as part of a new leadership team and a new effort to, expand our footprint, to turn the company around, to get our programs out to more students. So I'm happy to bring my expertise to both this podcast and to the company.
Okay. Well, I'll say, like what interested me about having this conversation is that, I do feel like that there should be a basic level of understanding. Again, I'm dating myself here, but like I was in high school when they did their first classes in basic, they just introduced the class, and I was actually teaching the teacher, to be honest. Because you learn shortcuts. And so he was he would be like, well, you do this. And I said, you can take those 10 steps and cut it down to 4 if you just do this. And he was like, oh, all right. But I am not a coder I did a whole bunch of stuff with BASIC when I was a kid. And that's about the extent of my coding. When I was in college, I did take it was a pseudo programming course.
Yeah.
And the thing is, I think that was very valuable because it wasn't. It's really just a logic class. It's you're not teaching any actual code syntax. It's just teaching the basic form of this is how a computer program flows. Yeah. And where I think Code Ninjas comes in and programs like that is I think that is a level of education that really should be required. But and then I guess that was where I was going with when I was in school and they introduced the computer classes. It was an elective. I mean, it's probably still an elective in most cases. If you want to go, if you want to learn, computer programming or whatever. But I feel like an entry level, a computer coding 101 ought to be a required course given the landscape today.
Absolutely, Tony. I mean, I can feel you there too. So, because when I was in college and high school, it was C++ programming and just getting into JavaScript as an introductory course in college. And that was Georgia Tech back 20 plus years ago, or around 20 years ago, or 15, 20 years ago. So I think because the students and kids today, especially ages 5 to 18, they're surrounded by screens. The games that they play are even more advanced. They rely on so much more code. Even businesses today, left and right, are dependent on code behind marketing campaigns, behind ads, behind product placement and all that. Everything involves code. So it's becoming a necessity, to your point, to teach young students not so much how to become hardcore coders. It's great if they can, learn Python or Lua and just start, typing out lines of code if they know how to use AI to their benefit. If their age is 13 and higher, but understanding the logic, how to break problems down and seeing it from that lens is becoming more and more important. And we see that with our kids today. And we serve 100,000 students on an annual basis. And our mission is really just, we want kids to have fun while parents see results. And those results aren't getting an A in the class. It's more about, is my kid understanding and appreciating what STEM education is and what a coding education is and what they can do with it. And then let them explore their passions. So you're absolutely right on the nose with that.
Well, and I think most high schools that I'm aware of, and I've got 7 kids, so I've dealt with it.
Wow, but you got an army.
Most high schools that I'm aware of do have a requirement for a foreign language. You don't have to take it all 4 years, but you do have to take something. And again, I understand the logic, and I agree. I agree that you should be exposed to these things. At one point, many years ago, I was making an argument that computer languages should just be part of that mix. If you tell me I have to take another language, it should be like, well, do you want to do Spanish, French, German, or C? You know, because it is another language. But then, I had a debate with it with some people about it, and was basically eventually convinced that wasn't the same thing.
I still fall back on my Spanish a lot when I go to Spanish-speaking countries, so I do credit my Spanish teachers to be rigorous with that back then.
Well, and that's a good example though of, it's not, I took Spanish all 4 years. I mean, I have a working understanding. Like if someone's speaking Spanish, if they're speaking it too fast, then I'm just lost.
Correct. Same.
But if I'm reading it, even now, I can decipher what it's about.
Yeah.
And if someone's talking slow enough, I can understand, okay, all right, I know you said this and I know you said this. And so I can put it together with context because I have a rudimentary knowledge of the language that allows me to understand what's going on. That's what I'm talking about with coding. Is not that I think that everyone should graduate high school as a developer, but that you should have a working knowledge enough that if I showed you a page of code, you could kind of look and go, okay, I see this is calling this module, and based on the name of this module, it seems like it's supposed to do this thing. And just to be able to follow the flow of the logic. It's like you don't have to be able to write the code, you don't have to be able to, whatever, but you should be able to kind of understand what the flow of the logic is if you're looking at code.
Absolutely. You're right on the nose about that. I mean, take my job, for example. I come from traditional curriculum development, teacher training, and things like that, but I have a rudimentary understanding of code and IT in general. So when I'm helping troubleshoot with students or helping troubleshoot with the corporate teams that I manage or even other teams, you find that it helps prepare you better to problem solve, helps you better understand the world around you. And I think the challenge for kids today is that there's a lot of extremes. They're expected to go to the maximum for their sports ability or to certain academic, like chemistry knowledge and all that. And a lot of careers today, like if you're a doctor, if you're an engineer, you do need that kind of knowledge base. But I think there's so much in the world to grasp around, especially for the kids, that giving them that rudimentary understanding in just coding and other areas, that gets them better prepared for life. Right. They just are better able to tackle real world problems and think in different ways. And I think we've lost some of that too, especially in the US, even as great as our schools are. We've lost a little bit of that around the world too. Just the ability for kids to just see something and interpret in multiple ways, especially in a coding lens.
Yeah. Well, first I was going to say, like, I'm in Texas, so when you talk about extremes, I grew up in Detroit. But I'm in
Detroit to Texas. Yeah.
And I grew up. I was never. I mean, there was a brief period where I was kind of the best baseball player, but that was when I was younger. But I was never like the jock, the all-star athlete. But I played every sport. I played baseball. I played soccer. I played basketball. I played football. I did all of them. And that was just the way I was raised. Is you did like we did sports year round, and we just whatever the next sport was.
Same. Yeah.
But
same.
Texas, the mentality here is extreme. The mentality is there's basically no such thing as recreational baseball or recreational football. Like whatever you're doing, you are all in. Like kids have personal coaches, like off on the it's like
travel teams too.
I mean, and raising my kids here, I was like, that was baffling to me. I was just like, can't you just play baseball because you think it's fun? Like
just have fun with it. Yeah, just go out and have fun. I was raised that way too. But I think it's a rubber band effect because we had the participation trophy mentality, I think, for the last 2 decades. But I think we're seeing a shift back to you got to be the absolute best. You got to, put your 10,000 hours in to become a master. So there's that clash. Yeah.
But going back to the idea of just having that basic understanding, I draw these parallels with, again, I grew up in Detroit in an era when you could actually open the hood of the car and understand what was going on and take the engine apart and put it back together again. I took auto shop in high school. I think cars are significantly different now. You need code ninjas so that you can work on your car.
Need your onboard computer to plug in to get the diagnostics.
But there are things like that, like being able to do just brake pads and oil change, or being able to troubleshoot a leaky faucet or replace a toilet. Like you, as a functioning adult, I feel like you should have a rudimentary understanding of plumbing, a rudimentary understanding of woodworking. You should know how to use some power tools. You should, understand, the basics of things. And it's like, it's not, again, you don't have to be an automotive expert. You don't need to be a master plumber. But even if you don't obtain enough knowledge to be able to fix it yourself, I think it's a matter of having enough knowledge to even understand what the problem is. It's to be able to do that basic troubleshooting in the first place.
100% agreed. And I grew up the same way. Like my dad and mom would teach me, like, you don't have to be the master at this, but like know how to change your tire, right? Know how to change your oil, like know how to. And I think even a step back from that is know how to take any kind of life problem you encounter and start breaking it down into ways you can understand on how to, block and tackle it, right? Hey, using their corporate word, but it's blocking and tackling. It's like, how do you break it down? What can I do? What do I need help for? And that kind of links to how a lot of students are afraid to ask for help, right? They think they got to do it all on their own, or they internalize their struggles and anxiety. But it all is linked together, where I think if students are, and parents too, supporting this, they're helping kids learn rudimentary coding skills. They come to services like us or other, or they, show their kid how to wrench a car, right? Or like, hey, we've popped this tire. This is what we do. Just your examples, how to fix a clogged toilet, right? Just using a plunger, and then maybe you got to get a wire hook to get in there. It just helps them prepare them for life, to be able to tackle the very, pushes and pulls of what they're going to encounter as they get older, especially as our world gets more and more complex. Even though it's more screens everywhere, there's just complexities in the world that we can't teach them in high school, can't teach them in middle school, even elementary. So 100% agreed.
Yeah. And I think, and a lot of people will go to that next level. There's like the intro level of like, I just kind of understand the very, very basics. Then there's there is that middle level of know enough to be dangerous. I when I was an IT and network admin, we had many of those working at the company. They knew enough to get in to break things, but not enough how to fix them. But the thing is that it's that hacker mentality. It's hacker in the benign, good, pure sense, not hacker as the cyber criminal.
Right.
But the understanding how things work. Like I have an uncle who is a developer. Actually, he's just a freelance developer. Has been doing that for decades. But when he was a kid, he was the kid that he got in trouble because his dad came in one day and he had dismantled the entire stereo, because he wanted to see how it works,
Yeah, that's great.
And so there are people like that. But so it's like there is, I think there are use cases for that too, where there are situations where it would be nice to not just be able to look at the code and say, okay, I kind of understand what this is doing, but to be able to look at the code and say, okay, I understand what this is doing, but I want it to do this.
Correct.
So let me just type a couple lines and see what happens.
And so you highlight two really good pieces there. One, it's understanding, does A equal to B? If I push this button or I put this line of code, does it do what I want? And can it do something better? And to that point, how can I make something better? Right? Igniting that curiosity in kids. And I mean, we see that at our centers all the time, where kids get that light bulb moment. They're like, oh, the power's in my fingertips to type in code, to mess around, to make mistakes, and then try to make things better or do cool stuff with the games I'm building. So you're absolutely right about that too. That's a great point to call out.
Well, and it's obviously a whole different world. I know there are multiple resources out there online to various platforms that will teach you basic coding and walk you through stuff. So like the way I learned basic, and again, dating myself, but the way I learned basic was it was just like I don't remember the name of the magazine. It was basically just a computer magazine.
Yeah.
And the computer magazine would always have one program, every month there'd be a program. So all the lines of code were there, and you had to just type them all in and then see what happened. And the thing that was valuable about it wasn't the typing it in, it was the fact that it was always wrong. And I don't think it was intentional on any part on their part. I think it was just a typo, but I had to figure out where the typo was in order to make the program work. So I would, after I spend like an entire weekend typing this program in, then I'd be like, okay, it doesn't work. Why? Now I got to go through and figure out, okay, what line has the error in the code?
No, I resonate with that because we teach our kids to do that too. So in their sessions, they're putting together lines of code, whether it's block coding, JavaScript, or Python, or even like the Unity game engine. They get spaces incorrect, semicolons are off, the parenthetical elements, there's one too many. So they're figuring that out. But what I'm surprised to see recently is that there's a rise of several AI companies that are driving, I guess, learn language models that are helping students and programmers identify where those issues are. Now, I'm caught in the fence. I'm 50-50. Like part of it, I think that's a really cool tool. It helps really facilitate like classroom instruction, helping, people learn in general. On the other side, I'm like, well, does it take away from that skill of figuring stuff out? Right. You'd have to sit
Maybe.
there for a long time figuring it out. Yeah, make your brain
Well, and that's,
gears turn.
I realize different people learn different ways, but, like when I was doing, I haven't done one in a while, but when I was doing like certification exams, the CISSP exam or Microsoft
Yeah.
NCSE exam, et cetera, and I would do practice tests as my primary method of studying. Like I have books and I could have like actually studied the books, but I would just take the practice tests and you get a bunch right, and then the ones you get wrong, it would break it down for you. I said, this is why it's wrong. And that was actually the most valuable part to me. Like the ones that I got right, I didn't really learn anything from that information, but the ones I get wrong, once I got it wrong and you tell me why I got it wrong, I'm like, all right, well now I've committed that to memory. I won't get that wrong, next time. So it's the failures I think are helpful. Like, if I would personally consider it valuable. Like I would need to have the basic understanding of like Python syntax or Perl syntax or whatever, the basic understanding of that. But instead of you just saying, hey, Tony, go write me a program in Python that does X, Y, Z. Once I have the basic syntax down, I think it would be more useful for me if you said, hey, Tony, here is a program that's supposed to do X, Y, Z. Figure out why it doesn't work.
100%. Yeah, exactly. Yeah, that's exactly how I think coding education should be approached. It's not so much saying students do or adult learners do step 1, 2, 3, 4, 5, and we'll get to this end product. It's more saying, I would like to have a game that has a character that does this and they move in this direction or they interact with objects this way. Show me how you like to do it. Right. That's how we instruct in our centers too. And there's a difference too. Like Tony, you're one of the rare, self-driven learners, right? I think kids nowadays, I think, need more and more guidance, especially I think the pandemic, increased the number of kids that benefited from hands-on instruction. But even our senseis, the tutors we call senseis, they're teaching our kids to look at A, look at B, and look at C, and creatively get there, however you like. We teach some core, syntax rules, specific lines of code that they should use, how certain modules should be built. But there's flexibility in code. That's the beauty of it. There's not always one particular way to code something. You can get to the same end state in multiple ways.
Right. Well, and the other thing, and you alluded to this earlier, the other thing I think, if you have that basic understanding of the flow of program logic, and you condition your brain to work that way when looking at, a page of code or whatever, hopefully, at least for some people, that also then bleeds into other areas of life. Like
Yes.
you learn, like so now when I'm going to go back to the like the clogged toilet. Now the toilet's clogged. Yeah. You can kind of think through okay, well, what's step one? What's step two? If I do this, then it's going to cause this. And it's like, it's just kind of gearing your brain for that sort of like sequential logic.
Absolutely. Because it goes, even though I think a step back, it's about engineering mindset. That's what a lot of the top engineering schools teach. It's not so much, you're becoming a master biomedical engineer or a chemical engineer or whatnot, but the training around it is, look at your problem, try different things, and what doesn't work, take note of it. It's a scientific method, essentially, right? Like, what are you trying? What are you observing? What's working? What's not working? And you can apply it and we apply it as adults to a lot of different things in life, right? My car won't start. Is the battery dead? Do I have is one of my spark plugs all messed up? I mean, you can't really get to all the stuff anymore because they, lock down all the engine covers, but it's that same approach, clogged toilet, or let's say you need to figure out directions to a place. So I recognize this landmark. I've been here before, or is there someone I can talk to? But even breaking that down, I think students nowadays, like ages 5 to 15, they do that in some parts of life. In other parts, they don't know how to do that same approach. So, coding
it's funny. It's funny because like when you were talking about when if I can use AI to write or troubleshoot code, then maybe that takes away from my abilities. There's definitely empirical evidence that is a thing at least for some people. And some friends and I were literally just having this conversation because a friend of mine from high school was talking about how he's got his one of his kids is 17, 18 driving around, and he was on Facebook talking about how she literally can't get from point A to point B without a GPS. And if you ask her, well, how did you get here? She doesn't even know. She just did what the GPS told her. And I was like, that's mind blowing to me. I'm like, I grew up delivering pizza. I just had the entire map of Southfield, Michigan memorized, and if you gave me an address, I just knew where that was.
What I think brain training for kids, like building like their muscle memory nowadays is different than what ours is, right? Like I think I grew up with Google, so I'm kind of dating myself too, but Google came out when I was in college, or like Facebook had come out when I was in school. So I had to print out MapQuest directions if it was like a 1,000-mile trip I was driving. But locally, getting around places, it was recognizing people that I usually see, or landmarks, or even being able to engage, like talk to people and say, hey, do you know where this is near where that is? Everyone's on their phone with GPS, A to B, like, where'd you go? And I was like, did you pass this? And they say, pass what? Right. The delivery driver for the training team we have in town today, the delivery driver was like, I don't know which landmarks you're talking about. And she's local to this area. She's a younger generation. So I think even from a coding perspective, coding, I think, is one of those subjects in the STEM fields and in all education fields that still forces students and learners to break things down. And I think that's a skill that we're starting to miss more and more as our generations, grow up. So,
well, and I think that more students need to be put in positions to dabble with these things in a, safe space, so to speak. In that, I've never really had this problem, but like I'm going to use like taking a computer apart. I just replaced the battery in my wife's laptop the other day.
Okay.
And it's this Asus laptop. I had to remove, and I'm not kidding. It was like,
is it the battery on the bottom? You have to
30. I remove like 30. You basically disassemble the entire laptop. To get to the battery. There were like 35 screws. And when I disconnected as a larger laptop, and the display part, it was kind of heavy, and I undid the screws and it fell forward, and I didn't realize it at the time, but when it fell forward, it unplugged stuff. So I get it all put back together, and I turn it on, and I can tell that it's working. There's power. I see things light up. I can hear it. It's like, okay, so my battery's working. I got that part right. Unfortunately, there's now nothing on the display, and I'm like, that's a problem. And so I had to work with that, and I eventually got it figured out. Combination of trial and error and some YouTube videos. But working with my kids over the years and stuff, I think so many people are reluctant to, like, that's like a dark art. That's a black magic box over there. Like, you don't open that box. And like, even like replacing a hard drive or replacing RAM, and on the one hand, there are legitimate concerns about static electric discharge and stuff, and there are safety precautions. There are precautions you're supposed to take to. I rarely, if ever, do those things. I just do it. I'm like literally just working on this laptop, like on the bed with the open bottom, touching the sheets, and and it generally works out fine. But I can see why you'd be afraid to do that. But I think if you had a situation where it was in a K through 12 type class, and you just gave someone a PC, like a desktop tower, and said, I want you to take this apart and put it back together again, it loses some of its magical power. It loses its mystique. If you're like, look, there's only like 5 things in here. Unveil the curtain. There's like, you got a motherboard, you got a power supply, you've got a hard drive, you've got some RAM. Like, that's basically it. A GPU. And it's like, it's not magic, and you can touch the things, they're not going to melt. And and it's the same thing with code. It's like, put someone in a safe space where you say, look, just do whatever you want. Like, it's not going to break anything permanently.
I think you hit 2 really good points, and you said this earlier too. It's learning trial by fire, trial and error, learning through failures. And you do need a safe space for that too, especially with the sensitivities and the complexities the kids today face. So like at our centers, we have structured curriculum, but we also build flexibility in there to say, hey, this is ABC. It's okay to mess it up. You have to mess it up in order to figure out what doesn't work and does work. And your computer example is perfect because I put together my own PCs, and you're right. It's like 5, 6 pieces you order to get it going. And if something doesn't work, you can pop up on your phone and look at YouTube or ask a friend for help. Um, but it is funny that the veil that everything else hides behind seems to be thicker, but it's not really. You can reach out and touch it. And at our centers we encourage that kind of behavior too. It's like, hey, it's not a scary thing. You're not going to break the world if this code doesn't work. Just keep playing around with it. Have fun with it. Yeah.
Right. But if you're like a AWS engineer and you're in the live production environment, maybe don't play around. That's not a safe space.
Yeah. No, Code Ninjas is lucky that we deal with ages kids 5 to 15, right? We're not training AWS engineers, no, we're not training Azure DevOps engineers or UI UX designers. So they have the serious jobs. If something breaks, millions of people are affected. That's what the safe space is, right? I don't think AWS is a safe space. You gotta know what you're doing to get into that area. But
it's a digression from this topic, but
okay.
I would say they do have a safe space. Like nobody should be hitting go in the production environment. Like you work in your safe space so that you can break it and then figure it out, and then you push it to production.
They do have staging, yeah. They got staging and development environments where they go to production. They do alpha beta testing and all that.
So hopefully, as we're recording this today, like the big news this morning was that like there's like this massive outage with AT&T Cellular. So I don't know if we're going to find out if that was it's either going to be a cyber attack or it's going to be someone did something bad with the code.
So it's interesting. So two of the trainees that my team is training right now, they have AT&T. I have AT&T. My service is fine, but they're out. So ironically, we're talking about finding directions. They have to walk their way over here from the hotel. They're of a generation where they grew up doing that, so they just figured it out. Walking down several blocks, asking people, looking at landmarks. But they made the comment like, "Oh, my kids would have been lost if the GPS went out. Like, I don't know what they would have done." So it's kind of funny you bring that up. Hopefully it's not the computer programmers behind the scenes that caused the issue. It's a cyber attack. That's also bad to say.
I was going to say, like, it's really like, well, you don't really want it to be this, but you also don't really want it to be that. I'm not sure which one of those is better.
Well, where there's a will, there's a way, right? There's always some shark out there that's always going to be, finding, weaknesses in the system. So it's always like one coming up over the other. The people who create the system versus those who want to break it. It's always, a constant back and forth.
Yeah. In terms of what Code Ninjas does.
Yeah.
Now let's delve into that a little bit in a little bit more detail. You say, you're working with K through 12
young students. Yeah.
Young students. So like, is it that kids register with Code Ninjas to come do something on the side, or are you working with school districts to like embed the curriculum in the school?
So I do have to answer that in two parts, I'd say. So we have around 350 to 400 centers that operate in the US, Canada, and UK. So they're actual, like tutoring centers.
Like going to Kumon.
It's like going to Kumon, going to another tutoring location, but we do coding, gaming design, robotics with Lego, things like that. Unity game engine design. So we have very particular coding languages we teach. And so we have a structured curriculum, but it's all teaching kids how to get used to and be friendlier with the languages they work with. But we also teaching classroom skills. Some of our youngest students, ages 5 to 7, they're in what we call the junior program, and they're more hands-on with STEM education and with coding. They use Scratch, the Scratch environment, but they're learning how to raise their hands, how to work with each other in small groups, how to talk to the teacher, how to resolve frustration. So it's another safe space, to a term you used earlier, where kids can feel freer to learn, to have fun. And we're very game focused, right? Our kids love games, so they're creating their own sprites, they're creating their own backgrounds, music, things like that.
I was gonna say, I feel like there's a whole generation of kids or a whole generation of now young adults who got their first taste of developing and got into it at all because they were doing Minecraft mods.
I got into it with StarCraft mods, right? Back in the day, StarCraft 1, just modding the game, making it work better to your specific preferences, customizing it to what you want. And that's where we see a lot of our kids start. They'll pick a summer camp. That's just, a topic around robotics or around one of our languages or building a game. And then their curiosity ignites because they're like, oh, wait, can I do this with that? Or that with this. So just like how we were inspired, I think today coding is more friendly. It's more accessible. It's easier to be creative with coding today because the platforms are a lot better. The coding environments are so much cooler. If I had coding just back in my day, I think my path might have been even different.
Yeah.
But I think it's pretty cool and fun.
Well, there's definitely been a number of times over my lifetime and career that I've been like, well, if only I had spent more time going down that path. I'd like to know, I'd like to know more coding than the basic that I learned 30 years ago. Is there, so you got the centers and stuff and the summer camps.
Oh, you spoke about school partnerships. Yeah, I didn't touch on that.
School partnerships. Is there, so let's say, someone, they've gotten their initial taste. Now they want to, is there a next steps or just Code Ninjas help, to kind of guide okay, well, what do you want to do? Okay, well, you should probably go down this Python path, or what do you want to do? You should go down this path.
That's a great question. So I'll say yes and no, because, with our older students, ages 11 to 15, they're in middle school, they're about to hit high school. There's that track into AP computer science, IB computer science with the high school courses. But the students at that age range, I think naturally through our curriculum are deciding what languages they resonate or they work with most easily. And they're already thinking, oh, do I want a career in engineering or computer science engineering? And our center directors, our senseis, they also help facilitate those conversations. So it naturally happens. I wouldn't say there's a set pathway though.
Right.
We say, hey, if you're good at this, do that, because I think within the computer programming fields, there's 3 to 4 dozen pathways already. Leading to becoming a full stack engineer or cloud engineer or, back end, front end type stuff. I mean, I think engineers nowadays know at least 6 to 7 languages, that work together.
Well, and I was going to say too, let's take this back to just spoken language.
Yeah.
If you're born and raised in America, speaking English.
Yeah.
And you don't know anything else, all of the languages just sound like gibberish. It doesn't matter if they're talking Spanish or German or French or Russian or whatever. It all is just you're not speaking English. That's all I know.
Right.
And I think if you don't know anything about coding, computer code is the same way. You look at it, you basically see matrix binary ring. But once you have a basic understanding of program logic, it starts to make a little bit more sense. And then the other part that I was going to say is that the way I understand it, and I'm not a developer. I have a son who's a developer, but the way I understand it is basically, it's okay, so I took 4 years of Spanish. One time I was on a date when I was in England, and we went to an Italian restaurant, and I'm sitting there, and all of a sudden my subconscious was heard the music and the lyrics, and I was like, why do I understand the lyrics?
Romance languages.
They're in Italian.
Similar.
And that's when I went and looked into it. I was like, oh, Italian and Spanish are almost identical.
Right.
You can definitely put those things together. And I think and to an extent, you can once you learn once you have English and then you learn Spanish or French or Italian, it doesn't mean that you know the other languages, but it does make it easier to pick them up or decipher them. I can look at French and to make some sense of it.
Yeah.
And coding's kind of the same way. It's they all have different conventions. They have different syntax, but the basic logic flow is at least similar.
It's a good example. We Americans, we learn English, right? So in coding, it's learning that first language, and then through that process of learning, your brain's rewiring to understand, oh, what is the flow? Why does A lead to B and not to C, right? And that you build that over time. It's like that in music too. You learn one musical instrument, you learn the cadences, the composition skills, the major, minor, augmented, diminished lines. I mean, I play piano, so playing piano helped me understand how music works for other instruments very easily. Now, I can't play guitar for my life, but if I hear guitar playing, I can recognize keys still to this day, right? How they're shifting, what the melody is. So whether it's music, whether it's sports too. Like you learn one sport, your body starts reconfiguring in a way where, muscle memory and all that works to your advantage.
And, well, and you just reminded me of another example or a related thing.
Yeah.
And it's okay. So like my daughter is a dancer, and
yeah,
she processes music very differently than I do, and so does my wife. And they can hear, they'll listen to something and go, like, what's the time signature of this? And they're like,
right.
yeah, I'm hearing this. I'm like, I hear music. That's what, right. Like I don't even know what words you're using right now. But
they
the thing
go through beats. Yeah, they're kinesthetic.
But the thing I was going to say is another example that's not directly related at all, but it's still similar. Is people who've never had beer try beer are like, oh, that tastes like crap. Why would you drink that? Same thing with wine. Same thing with coffee. But when you do drink it, you eventually develop the taste, and once you develop the taste, you taste that. Then you can detect the nuances. Correct. So like someone who doesn't drink coffee, just drinks, they don't care if it's a hazelnut or vanilla or like all of it is just bitter. It all just tastes like crap, and they're like, I don't get it. Whereas when you like if you're a wine connoisseur, then you can do things like, oh, I detect notes of blueberry. It's like, well, as opposed to just saying, I don't know, it just tastes like wine.
It's wine, yeah.
And so the example you were giving reminded me of that. It's like once you get that base level knowledge, then you can start to understand and detect the nuances and the layers above it. But as long as it's foreign to you, it's just all the same. It's all crap.
And I think coding is still seen by many as that always foreign thing, because I think that the imagery is, if in that movie, The Social Network, it's like, oh, you're going to plug in and write millions of lines of code. That's not really what it is in a lot of different projects that engineers work on, because there's more tools, there's more platforms, there's more learning space. So yeah, it's just yet another thing in life for us to.
It's also much more broken, most people, most like young adults now wouldn't even have this frame of reference. But like when I was in high school, the games were like, Ed Kim decided to write a game this weekend or whatever, or he devoted the last 6 months to writing this game. Game. Yeah. And now when you look at if you go look at Call of Duty, if you go look at Halo, it's a movie production. I mean, the credits go on forever. They're and so they're very specific roles. It's not like somebody sat down and wrote Halo. It's a very huge team wrote Halo, and Ed Kim's job. Ed Kim's job was to write the module that just does, what happens when you fire this weapon. Like that's it. That's the end of Ed Kim's job.
Yeah. Well, and we see that in our student base too. So our younger students, ages maybe 5 to 7, 8, 9, they're still doing like the basic character press. You press up, the character moves up. Go down. But they don't take 6 months now. They'll pump out a game in like 3 to 4 sessions. But it's very basic 2D. But then we have our older students working on the Unity platform, and they're storyboarding, they're creating music, they're putting in, different, like you can flip your views, and they're doing mini production. So it amazes me too, because I didn't, for me, it was like, oh, we got to wait 3 years for this game to be developed, and it's still going to be clunky, but I would still have to play it on, Super SNES for back in the day, right? So you're absolutely right. I mean, all the current modern games are incredible productions, so it is wild what coding can do and how far it can go, and it's going to keep advancing. I think that's why coding is so essential. Is it has a never-ending life, I guess, a life cycle. It just keeps going. Yeah, more applications.
Well, in the part, one of the things that I don't know if it's which one's the chicken, which one's the egg, but yes, it's this massive production and it's modular. Someone's doing the music, someone's doing this little bit, someone's doing this little bit, and it's this modular production. For those who don't have any knowledge of coding at all, I just want to put out there that that's basically how all coding is. It's all modules, and most programs today are a collection of modules of other programs. I mean, you're taking this little, You're taking, you don't sit down. It's like you don't reinvent the wheel every time. If you want your program to when I click the mouse, when I click this button, this happens. Well, I don't need to write the this happens part. I can go find that module on GitHub or an open source project, and I can pull in the module that says, okay, this happens. So I don't need to write all of that.
And it's like the mod packs that kids play with on Minecraft, or people who create mods for like the games that the kids play. They're not creating everything from scratch. They're pulling in what other people have created. So I think that's what's great about coding. I think if you really take a look at coding, you can break down things into those modules, and it's not about one person furiously typing for like 36 hours, 48 hours to create something, from scratch. It's finding inspiration in what's already been done. So that pulls in that engineering mindset, pulls in what we grew up with, right? Like, oh, my dad used to do it a certain way, but I can do it. Like you said, for your first basic class, you were teaching the teacher, like you could get to here 4 steps faster. So it's drawing upon that same mindset that, taking on life, on how to tackle any problem you run into. So some great examples.
Yeah. I mean, so like I said at the outset, I found the concept of Code Ninjas to be very compelling, and I do think it would be valuable. I think every child should have that introduction to coding, that basic understanding of coding, and again, it's not. I have enough understanding of coding to be able to kind of look at the logic flow. Yeah. I'm not writing any programs. I'm not gonna I'm not sitting here trying to mod Windows 11. But I just think that again, I think given the evolution of the world, just going back to I grew up knowing how to fix my car and basic plumbing, all these things. It's like, well, now my refrigerator is a computer. My oven is a computer. My television is a computer. Like everything is a computer.
It's a smart hub everywhere. Everything's linked.
Yeah. And and we talked about like the with the cars, like you can't even get to anything in the engine anymore. Now you need the little modules to plug in to get the codes. Which, side story, when you do that, like we've had some instances lately with my son's car acting up, and so it's like, well, you can go to AutoZone. You can go to O'Reilly or whatever. They've got the thing. They'll let you use it for free, and they'll pull the codes for you, and they'll say, okay, this is what it is. And I'm like, all right, I think we're at a point where why do I need that intermediary step? If the car knows the codes, why do I need an extra gadget to translate those codes? Instead of you just saying, oh, it's a 7.5G, like, why don't you just tell me cylinder 4 is misfiring? And it's like, I have a digital display in my car. Just put a message up there that says cylinder 4 is misfiring. You apparently know that information already. Why don't you just share it?
One of my more recent last cars, one of the cylinders was misfiring, and that you only need to plug in an OBD to figure that out, but it would spit out that report. My car now, they need a certified tech that plugs in an OBD and all this other stuff just to figure out the same issue. If you get a little hiccup when you're accelerating. So it is interesting that there's a pro and a con, right?
Yeah,
technology.
I just recently learned after my son's gone to AutoZone like 3 times in the last 6 months for various things. I just recently learned that you can get the ODB thing from Amazon for like $20.
Yeah.
And it connects wireless to your phone from an app. Yep. And I was like, I told him, I was like, just pick up one of these. It's like you can actually control things in the car through the phone when you have one of those. Like you can reset the oil light, or you can turn things on and off through the app. And I was like, all right, well, at least that's giving some control back to the owner. But yeah, the big thing that just kind of boggled my mind is I was like, you have a code, we know what the code means, but you're making me get another device or involve someone else just to translate it when you could just display that on the display. You could just tell me what that is and save all kinds of steps.
That's a great example, because I think I see that in a lot of business today too. They're putting in intermediaries because I think either out of convenience or like the fear, like the example of us reaching out, you touch something, you figure stuff out. That fear, there's a lot more of that. So there's all these intermediate services. Even like I love Geek Squad. They do a great job, I think, at least for what I've needed. But Geek Squad is like that. You see people saying this is not turning on, and then sometimes it's like, did you plug it into the outlet? And they're like, no. It's like the most basic things to figure out. But I mean, most advanced stuff, I think you need
Well, on
help
some
with. But
things, and
yeah,
I don't generally think of automotive stuff this way, but it is maybe true a little bit. But I look at like doctors, lawyers, whatever.
yeah,
It's like they have a whole different language they use that I feel is used to like demonstrate their eliteness or to
look,
to
I agree
separate
with
like
you.
it's not a bruise, it's a subdural hematoma. You're not bleeding, you're hemorrhaging. It's not a scratch, it's a laceration. And it's like
Right.
by using these fancy words, well, now you can charge me $150 for your opinion. If you just told me I had a scratch, I'm not paying you for that.
Look, I laugh even more because my traditional upbringing, from immigrant family, I did try the lawyer path, I did try the doctor path, taking the MCAT and all said, and I came to the realization too. I'm like, why is a cut four different words, especially on the chart that the nurses or doctors are going to write? You put some great examples there. It's like just say it for what it is. Speak in plain text, plain English. Make it more relatable, right? It
Right.
doesn't
Like
have to be this
so like,
lofty separation. Yeah.
right. So that like the doctor comes in, tells you you've got a subdural hematoma, you think you're dying.
It's like I have a what? What's that now? And it's like no, it's just a little bruise. It's like
right.
you got to make it sound like I have cancer.
You got a subdural hematoma, you're like, oh,
we get that for coding. We get that for coding. So part of our job is to demystify all that, right? So yeah, we know the complexity and the specific language and syntax, but I think what makes it more friendly and accessible through our services is that we try not to speak in those super advanced technical ways that scares away parents, scares away kids. But you see that in doctor, lawyer, even mechanics, right?
Well, that's where we started. It was like I feel like
Yeah.
like you're calling things
Any
complex words when there's a simple way to say that a layperson would understand.
Now, not to take away, they got to do a lot of studying, I think, to understand things in and out, but to relate that to the common person, to the everyday person, you don't have to use that kind of language. So, great point with that. That's hilarious.
So, all right. Well, yeah, I think we're good. Feel free, like, if you have anything else you want to add. But yeah, I think this was a great conversation, and
This was fun, Tony. Yeah, this was great. It was a lot of fun talking to you, and then it's great that we could relate. And can't believe you have 7 kids, man. I hope they all get into coding. They follow your that son who's a developer.
Well, yeah,
Come to Code Ninjas, Tony. You should stop by one of our centers and see what we're about.
Well, my youngest is going to be 18 soon, so I think that ship sailed. They've all made their decisions.
Oh yeah, well, maybe we can get him to help our kids teach some of our kids for a couple months left in his senior year. Where's he off to college? I'm just curious. Where's he going to school? Where's your 18-year-old going to school?
My youngest is not going to college. She's the dancer, so she's.
Oh, okay.
She's in a pre-professional dance program and going off to.
Oh, that's a dancer you were talking about.
Yeah.
That's awesome, though. I hope she finds a great dance company to work with, because I know that's a grueling field to get into too. It's very competitive. Yeah. But thanks for the time, Tony. This was fun.
Yeah, thank you.
All right. Have a good one.
I appreciate you investing your time to listen to the podcast, but I also invite you to engage on social media. Please go like our Facebook page and follow at TechSpective on Twitter and Instagram. You can feel free to let me know what you like, let me know what you don't like, let me know if you love it, let me know if it sucks, and let me know what products you'd like to see reviewed or what questions you'd like to see answered in future posts.